Today, we are going to share our experience of enlarging our body weight after visiting our relatives, or in particular, our grandma's house.
Hi, Grandma.
Just kidding. We are learning how to do enlargement with negative scale factors. First thing, of course, we're going to learn objectives. The first thing is to learn how to perform enlargement. Obviously, you need to learn how to draw them out, and then also need to learn how to describe them when the shapes have been enlarged with negative scale factor, especially under one single transformation. So the notes, if you have done the previous chapter or notes on enlargement on grade 4 topic, you will know a scale factor smaller than 1 will make a shape smaller. So even though the word enlargement doesn't necessarily mean we're making the shape bigger. If the scale factor is a half, that means we're making this shape smaller by half. Okay. Now, shapes that have been enlarged by a negative scale factor will often look like reflection or rotation by 180 degree. But one thing to remember is when the shape has a different size, it has to do with enlargement. Nothing but enlargement. Okay. So when it's only when a shape has the same size, then you should consider something apart from enlargement. So I'll just say again, different size, definitely enlargement. Different size, same size, definitely not enlargement. Okay. To enlarge a shape with a negative scale factor, we're going to first of all draw the rays to the corresponding points. Now, this could be a little bit tricky when it comes to enlargement with negative scale factor because the shape will be similar to like a reflection, as I said, or rotation. Then we could count the squares from a center of enlargement. We multiply the number of squares direction with the scale factor. And then, because of negative, means we'll count it in the opposite direction. I will show you an example later. But first, you're going to try the starter questions. So pause the video. These are just normal scale factor. Have a go with a question. When you're ready for the answer, you can press play. Here's the final answer. So you can see a shape. I've highlighted using a blue pen. And the starter question 2 is enlargement scale factor 3 at 4,4. If you got it right, well done, move on. But if you don't, I'm going to show you step by step how to work them out. So first thing first, we're going to join up the points from a center of enlargement. So we're going to join them up. So use a ruler and a pencil. Ruler, because you want to make it as straight as possible. And then a pencil, because chances are you're going to make a mistake, like I did when I did recording. I made lots of mistakes. But anyway, right, so next, you're going to count up the squares from the center of enlargement to the point. So let's say we take the first top, this point on the top. So we count from the center of enlargement, 1, 2, 3, 3 left and 1 down. So I like to write this on the side, 3 left, 1 down. Or some people actually would prefer 3 left, 1 down. Using arrow might be better, especially later when we do the opposite direction, it might be easier to visualize it. So scale factor 2 means we times it by 2, so it becomes 6 left, 2 down. So starting from center of enlargement again, so 6 left, 1, 2, 3, 4, 5, 6, and then 2 down, 1, 2. So we know the point is going to be there on the line. So that's why we draw the ray, because we know the ray, our points must line on one of our lines. Next, what we can do is we can count actually 2 squares from this point to this point is 2 squares down. So you can sort of just start from this point, build it up from this point. So 2 down, 1, 2, 2 down becomes scale factor 2 means 4 down. So 1, 2, 3, 4. So it's always here. So we've done the first 2 points. Now this tip of the arrow is right in the middle. So what we know is it's going to be in here is 1 right, 1 down. So it'll be 1, 2, 2 right, 2 down. So it's here. So we can almost join them up like that. Okay. Next, starting from this point, we go 2 left. So times it by 2, 4 left, 1, 2, 3, 4, 4 left. Same on the top left, 1, 2. So 1, 2, 3, 4 here. And then the one in the middle. So from the tip in here, so it's 2 to left. So on the tip, become 4 left, 1, 2, 3, 4. So you can see we can join up quite easily like this. So the main thing is to make sure you get the first point correct, I would say. Once you've got the first point correct, you can build it up from there. Next one, describe a transformation that takes from shape A to shape B. We know we can join up the corresponding point. From the top right corner of B, we could drop the top right corner of A. It becomes like that. Bottom right corner of B, join up the bottom corner of A. Next, if you do top left to the top left, now you can see they almost join up at one point, and then bottom left, they drop at that point there. So we know this is going to be an enlargement, scale factor. So from A to B, you can see it's getting 1, 2. If we count the length, the 2 squares and length on B, 1, 2, 3, 4, 5, 6. From 2 to 6, I mean 3 times bigger. So scale factor 3. At the center of enlargement coordinates, that will be 4 to right and 4 up at 4, 4. And that will be the starter. So the next bit, after we've done our starter, it's time to move on to actually learn how to enlarge with negative scale factor. So the first two examples in here, we're going to learn to, we've got two shapes in here. One is scale factor of -3 and one is scale factor of -1/2. So I'm going to show you one shape that's bigger and one shape that is smaller. So first thing first, we're going to select the normal one. What we need to do is we're going to connect the point with the center of enlargement. So use a ruler and a pencil ideally. So to make a line, okay, so make few raised lines. Try to be as accurate as you can, because if you're not, you realize the point will not be lying exactly on the line. The point that not reflected enlarged point. So first of all, what you want to do is you've drawn the line. Next, with the triangle, with some easier shape, what you can do is you can start from the first point and then build it up from there. So let's start with the top point in here. So I'm going to start with the center of enlargement and count my steps from the center of enlargement to the point. So from center of enlargement, 1, 2, so 2 up. I like to use the arrow, 2 up, and then 1, 2, 3, 3 left. Now, because of a negative scale factor, it means we first have to multiply by 3. So times it by 3. 3 times 2 is 6. 3 times 3 is 9. But the opposite, actually, I don't like to use left. Let's use the arrow, because opposite means I can do the opposite arrow. Now, using arrow will be easier than using a letter, because then your brain doesn't have to process it twice. Okay, L stands for left, and then flip it, it means right, so use R. With the arrow, you can just directly flip it, so it's much easier for your brain to process. So from the center of enlargement, again, 6 down, 9 left. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 in here. Okay. Next, from that point, once we've done the first point, we can sort of go from there, because that shape is sort of easy. So this length was 3 squares. When I multiply by 3 means 9 squares. So you can see the rate is going up. So that means we know the other point is definitely be upwards. So 9, 1, 2, 3, 4, 5, 6, 7, 8. Now you can see directly here. So you can have a good guess. And then next, what about this point in here? 2 ways. You can either count from the bottom point, or you can count from center of enlargement again. So if I go from center of enlargement, 1, 2, 2 left, times it by 3 means 6 right. So from the center of enlargement, count 6 right. 1, 2, 3, 4, 5, 6. That's that point over there. So we're going to connect these 3 points together. Now, this is the answer. So let me make it a bit darker. Okay. And I can see this triangle in here. So what you can see is, it's being reflected. It's not a direct enlargement. It's like a projector, but you're projecting on a different side. It's like when you try to take a selfie, the left and right sort of shift. When you take a selfie, your left face, sometimes left face looks better than the right. I don't do selfies, but what I'm trying to say is, having some awkward moments of doing selfies myself. Sometimes when you flip it, you realize, oh, hang on, it doesn't look the same when I look in the camera, and that's why. Similar thing in here, left and right, they moved. Okay, so it's like a reflection in here, small reflection. Right, -1/2. Now, before I do this example, I do have to apologize. Some of the points do not lie on the lines directly, do not lie on the grid. In the exam, the points should always lie on the grid. I'll tell you what I mean later. So first of all, again, first thing, I'm going to connect some points to the center of enlargement. Try to make the line as long as possible. Now, there are many points on this arrow 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Can't count. So, therefore, because if you make it 7, there are 7 lines, the whole thing will be quite congested. So what I'll do is I draw 3 first. Okay, so I do the 3 points, and then if I need more, I'll do more rays. I'll do more lines. So let's go from the top of the arrow. So from center of enlargement, again, always from center of enlargement, so you count 1, 2, 3, 4, 5, 6, 6 left, and then 1 down. Just kind of get 1, 2, 3, 4, 5, 6, 6 left, 1 down. Yep. Okay. A half means times it by a half. So 6 times a half is 3. 1 times a half is a half. Now, that's what I'm trying to say in the exam. When you times it by half, usually in the exam it will be a full number, so it will be a whole number. You won't have half a grid or half a box. Anyway, we have to do the opposite direction because of a negative. So left means right, down means up. So 3 right. So from the center of enlargement, count 3 again. 1, 2, 3, 3 right, and a half up. You can see that's the point over there. Okay, it's a bit awkward, but it is what it is. Next one. So I'm going to go for far left point in there. So again, from center of enlargement, 1, 2, 3, 4, 5, 6, 7, 8. 8 left. And then 1, 2, 3, 3 down. Times by half becomes 4 and 1.5. 3 times a half is 1.5. So 4 right and 1.5 up. So 1, 2, 3, 4, and then 1.5 up, 1.5. Now, as I said, you don't normally have a half a box, so bear with me. Next, this point in here is just one box to the right of that point. So you can see it's one box to the right. Therefore, when I multiply by half, it'll be a half to the left of that original point. So that'll be a half box left. So it'll be right here. Now, if that confuses you, just do it again. Okay, so let's say we want to do that point. So 1, 2, 3, 4, 5, 6, 7. 7 left. 1, 2, 3, 3 down. So 7 left, 3 down. Times by half means 3.5 right, 1.5 up. So 3.5 right. So from here, 1, 2, 3, 3.5, 1, 1.5 up. A bit messy, but you get it. So I can now connect these 3 points together. Right, so you can see the slight arrow on the one side. Next, I do this bottom left point. So from this inside point, I'm going 3 boxes down. So 3 boxes down. 3 times a half is 1.5. So I'm going 1.5 up. So from here, 1.5. So it'll be right here. So let's try to connect the point. Let's see if it works. You can see from the center of enlargement to that point, it goes through the point we just drew. So we know we're correct. So we're going to go there. Right. I'm going to connect this point to the center of enlargement. So continue to do more. And then you can see 2 boxes right means 1 box left, because 2 times a half is 1. Right, negative scale factor, opposite left. So 1, so it'll be right here. Now you start to see the whole shape, how it plays out. And then let's do this point inside, arrow. So it's a bit awkward again. This time it's 3 boxes up. So 3 boxes up, 3 times a half is 1.5. 1.5 up becomes 1.5 down because negative. So 1.5 in here. Next, let's do the outward point on here. Now, I said it becomes quite messy, so maybe what we can do in here is we can count from here 1 box to right, so it means half a box left, half a box. So that's half a box left will be right here. Right. So we can connect them together, and then from there we can connect them together. So that's the final answer. I know it's a bit awkward, as I said. I do apologize for the box being in the middle. You shouldn't have this in exam. However, the 2 practice questions later, you won't have this issue. Here comes practice question 1 and 2. So pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the final answer. So I've highlighted in blue, so you can check your answer. In an exam, you don't have to highlight anything in blue, as long as you try to shade it, bold it a bit, make the line a bit bolder, then you can, a bit firmer, then people can see, and that's the final answer. If you got it right, well done, move on. But if you don't, I'm going to show you how we can do it, step by step. So in order to do it, what we have to first of all do is, again, we do have to join up the lines, okay, join up the line points with the center of enlargement. So we'll do that. Right, actually make it as long as you can. Next, I'll probably start with the closest point, which is here. So from the center of enlargement is 1 left. Scale factor is -4, so I times it by 4, so it becomes 4. Opposite direction, right. Now you only do negative direction when it's a negative scale factor. Okay, negative direction, opposite direction, English. So from here, 4, right, 1, 2, 3, 4. So that point is right here. So we've done that point. Next, we can sort of build up from there. From this point to the right angle point on the left, so it's 2 left. So 2 left times it by 4 means 8 right. So you're counting from the new point you just drew. Alternatively, you can count from the center of enlargement again, but that will be a little bit unnecessary. So from here, 8 right. 1, 2, 3, 4, 5, 6, 7, 8. And then that's 1 up, so it becomes times by 4, 4 down. 1, 2, 3, 4. You can see it's right there. So you can see that that shape is formed. Okay, so I'm going to make it a bit darker, just so I know people understand this is my final answer. But examiner will usually know because they can see the points what you just drew and which matches with the final answer or the mark scheme, so they know. Right, practice question number 2. This time with -2/3. Everything works the same way. So first we're going to connect the corner of the shape to the center of enlargement. Okay. I start with the closest point. So from center of enlargement, again, from center of enlargement, it's like Mario. This is always the starting point. 1, 2, 3. 3 right. Times it by 3/2. So times it by 2/3. So 3 times 2/3. Okay. Divide by the bottom times the top. So 3 divided by 3 times 2 is 2. So that becomes 2. Opposite direction, left. So from here, 2. 1, 2. So that point is done. Next, from there we can build a rectangle out. 1, 2, 3, 3 right. 3 times 3/2, 2/3 is 2 again, so it becomes 2 left. 1, 2 is here. So that point is done as well. Next, if we start from that point again, we can go 1, 2, 3, 4, 5, 6. 6 up. Times by 2/3. 6 divided by 3 is 2. 2 times 2 is 4. So 4 down. So from that point, 1, 2, 3, 4 is here. And then you sort of knew you can finish the last point by guessing it has to be right here. So that's how you perform negative scale factor. After learning how to perform this enlargement with negative scale factors, now we need to learn how to describe them under single transformation. One thing students usually get confused, as I said in the beginning, is they get confused with reflection or rotation, because if you look at them, it looks like they have been reflected or rotated, especially when the shape is, like a triangle. It looks like they're facing a different way. However, as I said, when the shape is bigger or smaller, has different size, there's only one transformation that is relevant, which is enlargement. Any other translation, reflection, rotation are nothing you should be considering. Okay, it's like breakfast, cereal, or bread. I'm actually not a boring man. You can have anything else like chocolate. I'm just kidding. Don't let your parents know. To describe the single transformation, so first of all, what we need to do is, now, students get confused with this one is also because they don't know which point is connecting to which. Now, what you have to understand is enlargement with negative scale factor is almost like a rotation. So you need to think about when this shape is like a rubber. Okay, it's like rubber. There's a reason why I use a rectangular rubber for this lesson, because I can use this for a demonstration. So imagine you do a rotation 180 degree, then it becomes like this, right? So look at the corner of the rectangle. The bottom right corner, okay, if I rotate it, it becomes top left. So the bottom right connects to top left. I'm going to connect them together. And what about the top right corner? So the top right corner, if I rotate 180 degree, becomes bottom left. So you can almost say this point is center of enlargement, but let's do one more just in case. So top left corner, rotate it, becomes bottom right. So can you see all the lines are passing through the very same point, which is this -1, 1. So we can say, first of all, to get this question right, usually 2 marks, 3 marks, you have to say enlargement definitely for 1 mark. With scale factor, you can use SF scale factor. So how many times from A to B? So from A to B, 1, 2, 3, 4, that 4, and that's 2. Now you're making the shape smaller. So smaller means times it by a half. Okay, so it'll be -1/2 because opposite direction. So -1/2 at the center of enlargement, which is -1, 1. That's how you can get all the full marks. All right, let's try one more. So let's think about this time. Where the best thing to do is the easiest way to look at this question is the right angle triangle, the right angle. So right angle, so that because the right angle must be corresponding to the right angle point. Okay. Next, you need to think about, okay, so you need to think about when this point is here, again, use anything stationary. In the exam, you can use any stationary. Think about this. Top right corner, when I rotate that way, it becomes the bottom one. So this becomes the bottom one. So I'm going to align it with the bottom. But you can see because they both form a straight line, so we know that center of enlargement is right here, 0, 1. So again, enlargement with scale factor. This time from A to B, from 1 length to 3 is making the shape bigger. So it's 3, but opposite direction has been -3 at 0, 1. Okay, so I hope you understand it's not a difficult thing to perform as long as you know which point is corresponding to which. Know your team members. So know the point. All right. Here comes practice question 3 and question 4. Have a go, see if you're able to work out the scale factor and the center of enlargement using the lines and the rays. So pause the video, have a go. When you're ready for the answer, you can press play. Here are the final answers. So question 3, you can do, first of all, you can do the right angle from A to B. So it's enlargement, scale factor, -2, because you can tell by this length is 1 to 2. So scale factor is -2 at 0, 0. Or you can use the word origin, which is also okay. So origin. So you can use both. Origin means 0, 0. For question 4, use a rubber rectangle, quite useful. So go around here. So the bottom left becomes top right. So connect them. And if you draw all the 4 corners together, you can see they all meet at 1 point, -2, -2. So enlargement with scale factor, -1/2 at -2, -2.